Good morning, class. Today we will continue with our topic on measuring instruments. In our last lecture, we covered about oscilloscope. So you learned about analog oscilloscope and digital oscilloscope, and we discussed about different features and we compared both of them. Now our topic is about setting up and adjusting an oscilloscope. Okay, so all the procedure, all the steps, all the important stages are mentioned here, but it will be better for you when we return back to our campus and we are in the lab. Then I will demonstrate it, and I will highly recommend that you do it with your hands so that everything is clear to you. But however, I have placed a picture here just for your reference and all the setting up procedure, and I will go through it one by one so that you at least have an idea how to set up and adjust an oscilloscope. The manufacturer manual which comes with the oscilloscope, it must be referred for particular oscilloscope you are going to use. So oscilloscopes are made by different make and manufacturer, so they provide you with the manual. So you should first refer that so that you understand all the features. So one oscilloscope could be different from the other oscilloscope from a different make. It could have a different features or a slight variation. But the main function and main controls you will find similar in all oscilloscopes. To set up, calibrate, adjust an oscilloscope, there are a few basic steps that you need to follow. First one is properly grounding the oscilloscope and yourself. That's very important. Some are very sensitive. If you don't ground your oscilloscope and yourself, there is a band which you have to wear on your wrist, or it will connect. And this ground clip which you can see here, it is for that purpose. So the oscilloscope will ground yourself and the equipment so that you don't see any unwanted frequencies on the display. Any noise, any unwanted frequencies are moved away. Then is that you examine all the controls on your scope and set them to the normal position. When you go to the lab, sometimes the person who used the oscilloscope before you, he might have done adjust different knobs. So first thing that you set all the knobs, all the buttons to their normal position. Then you turn on your oscilloscope, set the volts per division control to 1. Volts per division, as I told you before, volts per division are on y-axis. So each box has some scale that we sometimes set a scale of 1 volt per division. Sometimes it is less than that or more than that. So you better from this control, which is volts per division, you can see here it is written, you make it 1. Later on you can change it depending on the signal, but at the first you can make it as 1 volt per division. Then set the time per division to 1 millisecond. Time per division is taken on x-axis, as you can see here, and its control is here. So this from here you can set it at 1 millisecond. These are the initial settings. Later on you can change it. Set the trigger switch to auto. So the trigger button are here. These are the trigger knobs. You have to set them to auto so that they automatically adjust your wave size and its speed for better display on the screen. Then is the connector probe to the input connector. So this is the probe. You can see here. You have to, there is a wire here. You have to connect it to the right channel. Some oscilloscopes have 2 channels. In this example here, there is only 1 channel. So you just need to plug it into the oscilloscope. Okay, in some oscilloscopes, like in our lab, you will find double channel oscilloscopes. Touch the end of the probe to the oscilloscope calibration terminal. So the calibration terminal of the oscilloscope is given here. So you have to touch the probe to the calibration terminal so that you see some kind of wave here. That would be a square wave. Okay, why we do that? We do that so that we confirm that our probe is working fine and it is showing some kind of waveform on the display, and that wave is fitting onto the display. If necessary, adjust the time per division and volt per division controls until the square wave fits nicely within the display. So after touching your probe with the calibration terminal, you see here that how the wave look like. So it will confirm that oscilloscope is functioning properly. The wave is being shown by the probe, and by these two controls, the volts per division and time per division, you can adjust the square wave being displayed here, and you can see that everything is being controlled correctly. So the square wave will be shown here when you connect your probe to the calibration terminal here. Once you have done all these checks, okay, then you can, if necessary, adjust the Y position control to the center and trace the trace vertically. The Y control, okay, there is a button you can click to adjust the Y axis position. It should be exactly on top of this line. Okay, if it is shifted left or right, you can move it onto here. You can see this position, horizontal position knob. You can move it so that you bring the y-axis exactly on this line. Same thing you can do for the x-axis, x position control to the center, the trace horizontally. So this also you can move up and down, okay, to bring it exactly in the center through this knob, which will position it up or down. If necessary, adjust the intensity and focus settings to get a clear trace. As you know that the wave is being shown on a CRT, cathode ray tube, or LCD. In case of digital oscilloscope, you can adjust its brightness, intensity. So these are the buttons, control buttons given here for intensity, focus, brightness. So you can make it adjusted to your comfort. So that's how you, before you start using your oscilloscope, you can set up the oscilloscope like that, following all these steps. When we return back to the campus, you will perform all of these steps and you will use the oscilloscope with your hands. Okay, next is a small topic about calibrating an oscilloscope. Calibration, it is the process to maintain the accuracy of the instruments. As you know that with the long usage of the instruments, after some time, or with a heavy usage, or due to the so many different factors, environmental factors, and the kind of use which you have been doing with your instrument's accuracy gets changed with the passage of time. Once it is new or once it is newly calibrated, it will be giving you accurate readings. But with the passage of time, it might shift a little bit, okay, and it could start giving errors. To fix that, you have to do the calibration process. In the calibration is the process of configuring an instrument to provide measurements within an acceptable accuracy range. So you have to bring back your instrument to some laboratory where they will test it and they will calibrate it and they will make sure that it's giving you the readings within an acceptable accuracy range. It means within some tolerance. Okay, so high accuracy equipments can give you can give you reading of plus minus 1% or 2% tolerance. Okay, or other instruments could go up to 5% plus minus 5% tolerance. Depends on the instrument, depends on the what acceptable accuracy range is. If oscilloscope is out of tolerance, then the measurement will result in false information leading to incorrect decisions, damages, and expensive repairs, etc. So that's why sensitive instruments or those instruments based on which you are going to take some important decisions, they must be calibrated after a fixed interval. Sometimes it depends on the instruments and its usage and some other factors. It depends what should be the interval of calibration. Sometimes could be after 3 months, sometimes every 6 months, sometimes on annual basis. The oscilloscope calibration process and interval must be as per the manufacturer recommendations. So manufacturer recommendation is the reference point from where you can see how much the interval should be. Below mentioned controls of oscilloscope should be calibrated when due. If we talk about oscilloscope, then these are the areas which should be checked when it is due for calibration. The vertical channels and horizontal channels, both. Internal calibration signals, the calibration terminal from where you connect the probe to see the waveforms. That's the internal calibration signal. You need to get it fixed from the calibration uh, company, whatever their company you are using for calibration. Cursor and measurement readouts. The cursor positions, the zero position and measurement readouts, the values it is showing, are they within tolerance range or not, and the bandwidth of the oscilloscope. So all these 5 areas, it will be calibrated whenever you give it to a company for calibration purposes. So this was all about the setting up of oscilloscope and calibrating an oscilloscope. I will stop the recording and open the session for question answers.